While we have this file open here, I wanted to take another look at how we might accomplish this without using code. I think it can be a little scary when just getting into Houdini and you're already coding and having to do things you might be less comfortable with. So let me show you another way. There is a thing called an attribute Vop. I'm going to just start typing attribute Vop in here, and I'm going to wire our pig right into that. And we'll enable that. So if we go inside here, we are presented with two different nodes. There's an input and there's an output. The input is configured to fetch a lot of common attributes that are already stored on geometry. And the output here is where you would wire a lot of common operations. So typically affecting positions, velocity, force, color, or normals. You're not limited to this. You can wire anything out. There are some methods for doing that, which we might get into in further lessons. But for now, let's just deal with the basics. And let's try to replicate what we did previously with code. So we know we want to start with position, and we are going to want to add some value to that. However, we only want to add to the y value. So we need to split this up. And this is a vector. In here, we can even see down at the bottom, if you watch here and I hover over it, will tell us that it's a vector. We can also tell by the way that things are color-coded. So this kind of light green color, these are for vectors. This bluish color here, more like a seafoam color, if you will, is float values. Integer values are this darker blue color. And then string values are this kind of peachy color here. So we need to do a vector to float. Let me see where that is. Vector to float right up above here. And we will wire our position into here. We know we are going to add something to the y value. So I'm going to plug our y value into add. And then to write our final position, we need to convert back into a vector. So we will do float to vector. Now our x is the same, so x goes to x, y is modified, that goes into y, and then z, our original z, goes back in, and finally we go back out to position. So adding into here, we need to grab a random value that was based on our point number. So I'm going to type the word rand and grab that first one, random. We're going to plug that into our point number here. Now, to match what we had before, we need to just turn off this clamp position to integer in here. What this means is you won't get any different random values if the input coming in is between the integer values. So an integer, a value of 1 would most likely produce the same random result as a value of 1.10 coming in. It just changes the behavior a little bit of how this matches what was coming into Vex, because it's actually internally calling a different function. So I'm doing this for demonstration purposes to make sure that everything looks the same by turning that off. So we will take our random and we will plug that into our add. Now that was a bit too high, and if you'll recall, we took this value coming out of random and we multiplied it by 0.1. So let me multiply, and I can just drop that in here. We need to feed something in here. So I can feed in a constant value of 0.1. And now we have built this network. And if we go back and we compare the two, they are identical. Now, it took a bit of work to do this. And here we split this up into two different nodes just for sake of readability. However, this could easily be done in one line of code here. I could pretty much just say over here, let's disable that one, that instead of writing a new attribute here, we have b at p.y plus equals to this random point number times 0.1. And I've done something wrong because I haven't put a multiply in here. And of course it's 0.1. There we go. So in one line of code, we wrote something in about 5 seconds if I didn't make any mistakes. That took quite a bit longer to do here. Now, one thing to know about these networks here is that they are compiling code. If you right-click here and you go into the Vops options here, you can actually see the code that's being written. So you put a bunch of nodes down, and then when you're done, it actually generates Vex. So there's a lot going on here, but if you look, essentially it's telling you all the nodes that you have put down here. So there's the random node here. We can see that it's going to be calling this random value. It's feeding in our point number. It's doing a lot of the same things that we're doing over here, except it's doing it graphically. Now, because these are both code-based, when you make changes inside here, it takes longer to update because it is actually compiling the code. So just adjusting values here, it's a bit sluggish, it's slow, and this isn't how it's meant to be used. If you wanted to adjust values for a user to be able to manipulate, you can't be using something like a constant. You actually have to be using something that is promoted outside of this context here. And I'll show you how this works. We're going to delete that, and we'll put down something called a parameter. I'm going to take the parameter, and I'm going to wire it instead into here. So just for label's sake, we'll call this myparm. So that's the internal name of this parameter. And now the human readable label, I will call this my parameter. If we go up one level, what you'll see is now we have something here called my parameter, and we can freely play with that. This same behavior can be done through here. It just has to be done through code. So the way we would do this is we would define a channel in here. So we can say we have, well, we'll define a variable first. So we'll say that there's a float variable here, and we have to give it a name. So we'll call it myval, and that's going to be equal to a channel that we will create for ourselves, which is just going to be called myval, and we'll add a little semicolon to close that. So it's doing nothing right now. If we click this little button here, it will actually create that for us. It looks at the code and says, oh, you have a channel that's referenced in here, but it doesn't exist. I'll create that for you. Then we simply have to replace this value here with my variable. So myval is equal to that now. And now we have the exact same functionality that's built in. So two different ways of doing the same thing. One is purely code-based. The other is using a graphical interface for doing the code.